What is up, you guys? Welcome back to Keeping Up with the Cell. I'm Abby, your host, and this week we have a crap ton to catch up on. So, for some reason, this week, the Cell just had major issues, major mess ups, major cleanups. Because, for some reason, during translation, proline replaced every single alanine. I mean, what the heck? As we all know, alanine and proline are two completely different amino acids. I mean, just looking at them and their shapes, you can tell that they have very different functions within the protein and the protein folding. Now, here at Keeping Up with the Cell, we just want to make sure it's said that we appreciate both amino acids equally. But with this whole thing, the whole cell turned inside out. I mean, proteins were not folding properly, and a blame game amongst the organelles commenced. That's why I, your reliable source, am here to get to the bottom of the drama. Alright guys, so my first guest today is EF1 alpha, a monomeric GTPase that's supposed to make sure that the correct amino acids are added to the Whoa! I do not like how you just said supposed to. This whole mess is definitely not my fault. Right, of course not. I am so sorry. Then, would you like to describe your job in the cell?
Yeah, okay. So my name's EF1 Alpha, but everybody calls me Alf. In the cell, I make sure that the tRNA I bind with matches the mRNA codon, in the ribosome's acceptor site. And I'm gonna tell you right now, this whole mess is definitely not my fault.
Okay, I kind of see where you're coming from, but from the job that you just described, it kind of sounds like the job you have is incriminating within itself. Can you explain why it's not your fault? And if it's not your fault, then whose is it?
Okay, so my job is labeled the proofreader, but I don't actually read the codons. The codons are what's messed up in all of this. Anyways, I block the amino acids from binding with each other until the codons read each other and match. Once they match, my GTP goes to GDP. My power goes out. So how can it be my fault that they read each other and then turn me off? This whole thing has dragged my name through the mud and I'm sick of it. Literally, I just showed up to do my job. And I did.
Okay, Alf, you make some good points, okay? I think you need to keep telling your story. Now that you've put your side out, do you have any idea of who's actually behind all of this?
You know what? Actually, I do. I bind the tRNA after it's made. So either there's a problem in the amino acid is loading or a problem in the codon. A codon could be a problem with the tRNA or a problem with the mRNA, but not me. I want that clear. My name should not be in all of this at all.
Alright, thank you so much for being here, Alf. And for my listeners, stay tuned. We just have a quick break brought to you by our sponsor, CellGrow. CellGrow. Hi, cells. Have you ever felt weak? Your filaments not what they used to be. Try Filastrength. It's a new milkshake designed to give your filaments that extra boost they need. Alright guys, I am back with a tRNA molecule, trying to understand what exactly is happening in the cell. So tell me, what the hell is actually happening? Okay, so honestly, Abby, I have no idea. I've been going over everything I've done in the past few days and nothing seemed out of the norm. I mean, I've had a pinching feeling at the amino acid binding site, but I thought that was more me than anything. I'm getting kind of old. Okay, that's fair. For the listeners out there who don't know, can you kind of describe your role in the cell? Yeah, totally, for sure. So I bring the amino acids to the ribosome and the mRNA complex so that it can add the amino acid to the P site and create an amino acid chain that'll become a total protein. Oh, so you have the amino acid from the start? I don't know how I'm feeling about that. Yeah, and I totally know where you're going with that, but I am not the one who adds the amino acid onto myself. In the cell, you have to trust all the guys around you because we're basically all in assembly lines. What I do affects so many people down the road. That's why I take my job totes serious. Like, it's the most serious thing in my life. So, do you think that pain that you were feeling earlier this week has anything to do with what's been happening? I mean, you said it was in your side. Isn't, like, that where you bind the amino acid or anything? You know what? I think you might be right now that you mention it. I don't pay much attention to the amino acids I carry because between you and me, they have a bit of a god complex. Like, it's kind of concerning. It gets totally annoying. Like, ooh, I'm an amino acid that controls this, and ooh, I actually control this process too. I control you. Gosh, it's so annoying. Like, I know you're important, but I'm the one making you. I put you in this world, and I can totally take you out of it. I mean, that's what my mom used to say too. Okay, I think that's all we have left for you in this podcast. Thank you so much for coming today. Wow, guys. I think we kind of hit a sore spot on that last one. I mean, didn't mean to bring that up, but you know, it's okay. At least we know that the tRNA probably isn't the thing that's causing it. But what tRNA said kind of made me curious, and I looked into who loads the amino acid onto tRNA, and it's tRNA synthase. I think that this is who we really need to talk to right now. Hey, welcome to the podcast. So, if you could do me a quick favor and just briefly introduce yourself to the audience and give like a little description of what you do in the cell.
Hey, what up, dude? I'm tRNA synthase, but you guys can call me Tace. I basically load the amino acid onto the tRNA. I have a binding spot for the amino acid and a binding spot for a tRNA, and when they both are in the binding spots, well, hey, I link them together by hydrolyzing ATP.
Oh, cool. So, do you think you may have done anything recently, like differently, to do with what's been going on with the cell recently, like all of the shiitake mushrooms that's gone down?
Oh, no, for sure, dude. Like, that's totally not me. Like, I don't know what's been going on, but that happens way down the line for me. Like, that is totally not me.
Oh, okay. So if you're so sure, I just wanted to ask, like, you mentioned you had a binding spot for the amino acid and a binding spot for the tRNA itself, right? So I was just wondering what codon code you have.
Oh, yeah, totally. I have a GCC codon.
Oh, okay. So what amino acid have you been binding to?
Oh, I've been binding to proline, you know? My good friend proline.
Oh, okay. Oh my gosh. Do you know what GCC codes for? Like, are you sure you know what GCC codes for?
Oh yeah, proline. Like my friend proline, my bestie, my buddy proline is what GCC codes for. Totally.
Actually, no. No, it's not. Proline is CCCG. GCC is actually for alanine.
No, bro. Are you for real right now? Like, are you actually serious right now? I gotta go.
Oh my gosh. I mean, I actually just solved the mystery. I mean, guys, you should be proud of me. For the listeners at home, we just cracked open the case. I mean, wide open. We now know that the cell's problem originates from a mutation that tRNA synthase has, where it binds to proline and not alanine. I mean, who would have thought? I mean, that means that the process from the moment that tRNA synthase binds to proline, it's messed up. The whole process. Who knew one little mistake could cause so much chaos in a cell? I mean, now that we've had such a breakthrough moment on this podcast, I mean, we may hit top of the charts. What do you say, guys? I just have to thank you guys for listening. As always, you'll hear from me next week. Just make sure that you leave a like and a rating. See you guys.